Hi everyone. Before we come to the solution for each individual set, let's start with a brief overview of the difficulty level of this section. So this was definitely challenging in the exam environment. It might not seem that way when you are looking at the solutions now. All the sets will seem manageable. None of the sets is extremely difficult. But you have to think of it from the perspective of solving these in an exam, where of course you have very limited time and you have exam pressure on top of it. So from that perspective, you will see that there was only one set which was very clearly an easy one. All the other sets, it would have been difficult to identify which one of them were more manageable, which one of them was less manageable, because of the nature of the conditions given. Basically, you had very few conditions for most of the sets, and the conditions were pretty deductive as well. Or it was difficult to think what kind of a table we need to make, or maybe there were too many diagrams that were required. So because of all of these, many people had difficulty choosing the second set after the first obviously easy one. And that is why it was difficult to solve three sets from this paper in the exam. So keep that in mind. And now let's get started with the solutions. This set was clearly the easiest one of the entire section. It was a straightforward set where we had straightforward graphs, where we had examples given, where we had the entire process explained. So we did not really have to make deductions here. We just had to understand the nature of the information given and then do the calculations required for the different questions. So clearly the first set that should have been attempted by everyone, very much solvable within 10 minutes. We've been given that there are 5 countries which engage in trade with each other. Each country levies import tariffs on the other countries. And then it has been explained that the import tariff levied by country X on country Y is calculated by multiplying the corresponding tariff percentage with the total imports of country X from country Y. Now we can see that in the first graph, we have the tariff percentage that has been mentioned. And then in the second graph, we have import tariff that has been mentioned. Now, of course, the process is that import tariff is calculated by multiplying tariff percentage with total imports. So we have import tariff, we have tariff percentage, we don't have total imports. And the questions will be based on that. Then we've been given that the radar chart depicts different import tariff percentages charged by each of the 5 countries on the others. And then very conveniently, we have an example. For example, US, which is the blue line in the chart. So we have to look at the blue line for US. And charges 20%, 40%, 30%, 30% import tariff percentages on imports from France, India, Japan, UK, respectively. So we can just verify that so that we have a confirmation that we understand the chart properly. So we can see US. What percentage does it impose on France? So if we check France here, we can see France is here. And for US, of course, we are looking at the blue line. So we can see blue line is here. And clearly that is at the 20% level, which is what has been given in the example. You should know this, that this part is the 10% level, then this part is the 20% level, this part is the 30% level, and so on. So clearly, US is imposing 20% tariff on France. Similarly, if we check for India, so US is imposing, we can see 40% tariff on India. And similarly, if we check for Japan, US is imposing, look at the blue line, it is imposing 30% tariff on Japan. And similarly for UK here, it is imposing 30% on UK as well. So we could have just looked at this example and then just compared it with the chart to have that confirmation that we understand this first chart properly. And similarly, we have the bar graph. The bar graph depicts the import tariff levied by each country on other countries. And we have an example. US charged import tariff of 3 billion USD on UK. If we look for US here, okay, these are the import tariffs charged by US on different countries. And we have to check how much US is charging on UK, which is the black one. We check the black one here. We can see the black one is exactly at the level of 3. So now we have an understanding of the second graph as well. Now, after this, it has been given that assume that imports from one country to another equals the exports from the latter to the former. So for example, the import of, let's say, India from France will equal the export of France to India. Okay, so import by one country from another is equal to the export from the other country to the first country. Then it has been given that the trade surplus of country X with country Y is defined as follows. Trade surplus is equal to exports from country X to country Y minus imports to country X from country Y. So basically for any country, it is the exports minus the imports. And finally, a negative trade surplus is called trade deficit. So if exports minus imports is positive, that will be a trade surplus. If exports minus imports is negative, that will be called a trade deficit. So now that we have a good understanding of the data given, let's take a look at the questions. So if you come to the questions, there were 4 questions here. You can see the questions are pretty straightforward. And all of them are either about import-export or about trade surplus. And trade surplus is, of course, calculated through import and export. So we can see we just have to keep calculating the imports required to answer the different questions. And we can see that there's no question which is asking us to compare the imports of all the countries and see which is the highest one, for example, where we will have to find out all the values. We don't have any question like that. So we should not waste time calculating everything, but we should come to the questions individually and see exactly what is required to answer that particular question. So let's come to the first question. Now, the first question is asking how much is Japan's export to India worth? But the data given is all in terms of import. So instead of export, we should look at it from the perspective of import. So you're looking at Japan's export to India. That means it is the same as India's imports from Japan. Okay, so let's look at it from India's perspective. And let's see how much India is importing from Japan. So if I just write that here, India importing from Japan. Now, first of all, we have to look at this paragraph, which is giving us the process required. So this paragraph told us that import tariff, which is what we have in the bar graph, it is calculated by multiplying the corresponding tariff percentage with the total imports. So if you're looking at India's imports from Japan, first of all, let us see what is the tariff percentage. So India is here represented by the green line, and we have to look at Japan, which is here. And we can see green line for Japan is at the level of 50%. So India is importing 50%. India's import tariff percentage on Japan is 50%. And now this tariff percentage, we have to multiply with the total imports. Let's take the total imports to be T for total. So we'll have 50% of the total imports. This will be the multiplication. And this will be equal to the import tariff. Because this is the process explained, that we calculate import tariff by multiplying the percentage with the total imports. So import tariff, if we check, we are looking at India's imports from Japan. So Japan is the yellow one. So we look at the yellow bar. And we can see that the yellow bar is between the levels of 3 and 4. Between 3 and 4, so that will be 3.5. So this will give us 3.5 here. So this will give us that the total imports of India from Japan is equal to 3.5 divided by 50%. And of course, this calculation will give us 7. So that will be the answer here, option 4. But now we will keep this in mind for further questions so that we can solve them faster. That if we want to calculate the total imports for any country from any other country, it will be the value given in the bar graph divided by the corresponding percentage. For example, here, if we had to calculate the imports here, what did we do? Ultimately, we took the value in the bar graph, which was this 3.5, and then we divided it by the corresponding percentage of 50%. So keeping this in mind, we will be able to solve the other questions quickly. Here, the question is asking which among the following is the highest. So here, of course, we'll have to calculate the values for each of the 4 options. We'll go one option at a time, but just keep in mind that 2 options are talking about the value from the perspective of imports, whereas 2 options are talking about it from the perspective of exports. Now, imports will be direct, but exports, we will have to think about it from the other perspective of imports, because of course, the data given is in that format. So if we check option 1, in option 1, we have to calculate the imports by US from France. So we've seen that it will be the value given in the bar graph divided by the corresponding percentage. So if you look at the bar graph first, we are looking at imports by US and from France. France is the red one. So we can see the value here is 6. So we'll have 6 in the bar graph and we'll be dividing this by the percentage. So we're looking at import by US, which is the blue line, and from France. France is here. So blue line with respect to France, we can see it is at this level, which is at the 20% level. So of course, we'll be dividing by 20%. And 6 divided by 20%, 6 divided by 1 by 5 will be 6 into 5, which will be 30. So the first value is coming out to be 30. Similarly, we'll check the other options. So let's come to option 2. Now in option 2, we have to see exports by Japan to UK. So reversing the perspective, we'll think of it as imports by UK from Japan. So if you're looking at UK's imports, we have to look at the UK field here and from Japan. So Japan is the yellow one, which we can see here, which is at the level of 6. So we are getting 6 again. And now the percentage. So we are looking at UK from Japan. So black line with respect to Japan, that is at this level, which is the 40% level. So we'll have 6 divided by 40%. 6 divided by 2 by 5. So that will be 6 into 5 by 2. That will come out to be 15. Same way, let's come to option 3. So option 3 is imports by France from India. So we have to look at France and from India, which is the green one here. That's between 6 and 7, so 6.5. If you look at the percentage now, we are looking at France. So France is the red one. And from India, India is here. Red one with respect to India is at the 40% level. So this will be divided by 40%. Now, if we calculate, of course, we can see here that this will not be more than 30. And we are looking for the highest one. So we don't really have to calculate as well. So we can see 6 by 40% was just 15. Now 6.5 by 40% will be slightly more than that. But 30 is double of 15. Now clearly, this will not cross double of 15. So definitely this will not be the highest one, but still we can calculate. So 6.5 divided by 2 by 5, 6.5 into 5 by 2, 32.5 divided by 2, that will be 16.25. As I said, clearly not more than option 1. And now, of course, we'll come to the last option. So if you check option 4, exports by France to Japan. So that is imports by Japan from France. So we are looking at imports by Japan. So we'll look at Japan's field here. And from France, France is the red one. So we can see the red bar is here, which is at the level of 3. So we'll have 3. And the percentage, we are looking at Japan's imports, which is the yellow line, and from France. So France is, of course, here. And we can see yellow line is at this level, which is at the 30% level. So we'll have 3 divided by 30%, 3 divided by 3 by 10, which means 3 into 10 by 3, which is simply 10. So out of these, of course, the highest one is 30, which is there in option 1. In this question, we have to find what is the trade surplus or trade deficit of India with the UK. So we are looking at it from the perspective of India. Trade surplus or trade deficit of India. So if we look at India, we will look at India's imports and also India's exports with respect to UK. So first of all, if we come to the imports, we are looking at India's imports here from UK. So we look at the black bar here. That is, of course, at the level of 5. And if you look at the percentage, we are looking at India, which is the green line. And we are looking at UK here. So we can see green line with respect to UK is at this point, which is, of course, at the 20% level. So we are getting 5 by 20%, which will become 5 into 5. So that will be 25. So this is India's imports from UK. And now we also have to look at India's exports to UK. So we will think of it in terms of UK's imports from India. So we are looking at UK's imports from India, which is the green one. So we can see that is at the level of 3, of course. And now with respect to the percentage, we are looking at UK, which is the black line, and at India. So we have this level here, which is, of course, the 30% level. So we are getting 3 by 30%, which will be 3 into 10 by 3. So that will be 10. So we can see finally that we have India's imports from UK as 25 and exports to UK as 10. Now trade surplus is exports minus imports. So exports of 10 minus imports of 25, that is giving us minus 15. And it has been given that a negative trade surplus is called trade deficit. So here we are getting a trade deficit of 15. And therefore the answer will be option 3. This question is asking, among France and UK, who has trade surplus with US? So first let's look at France. And we have to look at France's imports from the US and exports to the US. So first we'll look at imports and then exports. And similarly after this, we'll look at UK. So we look at France's imports from US. So we're looking at France and US is the blue one. So we have blue one at the level of 5.5 here. If you look at the percentage, we have France, which is the red line, and US. So red line with respect to the US is here at the 30% level. So we have 5.5 divided by 30%. That will be 5.5 into 10 by 3, 55 by 3. So that will be 18.33. And similarly, we have to look at France's exports to the US, which means US's imports from France. So we are looking at US, imports from France, which is the red one. So that is, of course, 6. And if you look at US here, that is the blue line. With respect to France, that is at this level, which is 20%. So 6 by 20% will be 6 into 5. So that will be 30. Now we have to see whether it has a surplus. So we can see export minus import, 30 minus 18.33. That will of course be a positive value. And therefore France definitely has a trade surplus with US. Now similarly, we'll look at UK. If we look at UK's imports and exports with respect to the US. Imports first of all. So we have UK here, we have US as the blue one. So that is at this level, which is 2.5. And if you look at the percentage, UK is the black line. We have US here. So that black line with respect to US is at the 20% level. So we are getting 2.5 by 20%, 2.5 into 5, that will be 12.5. And similarly now we look at UK's exports to US, which will be US's imports from UK. So we have US, UK, black bar, which is at the level of 3. And now percentage, so we are looking at US's imports, the blue line, and from UK. So blue line with respect to UK is here, which is clearly at the 30% level. So we're getting 3 by 30%, which will of course be 10. Now for UK, we can see exports minus imports is 10 minus 12.5, which will of course be a negative value. So UK does not have a trade surplus with US. So we can see that only France has a trade surplus with US, and therefore the answer will be option 2. Now this set is an easy to moderate set, as we will see. In fact, it is more towards the easy side. But the challenge would have been to identify during the test that this is a manageable set which should be attempted. Because when we take a look at it, we can see the conditions are very limited. They are deductive. And it's not just about basic arrangement. We have different turns that the people are taking. They are moving around. And the arrangements keep changing. So you'll have to make a lot of different diagrams for all the different arrangements. Considering all of this, this was a set that many people would have hesitated with during the test, understandably. And that was the challenge with respect to this set, which is actually easy. So we have a round table which has 7 chairs around it. The chairs are numbered 1 through 7 in a clockwise direction. So of course, we have to follow this numbering. Then 4 friends A, B, C, D sit on 4 of the chairs. And the starting position, E and C are sitting next to each other. While for B and D, there are empty chairs on either side of the chairs they are sitting on. So of course, we have to keep track of this condition, which is with respect to the starting position. And of course, out of the 7 chairs, only 4 of them will be occupied because we just have 4 people. Then the friends are taking turns moving either clockwise or counterclockwise from their chairs. The friend who has to move in a turn occupies the first empty chair in whichever direction he or she chooses to move. So from this, we can understand that in one turn, only one person will move. Now that person can move in either direction, clockwise or counterclockwise. So that is also something which makes the set a little bit tricky at the beginning when we are analyzing it, because it could be any direction. And then we have been given that the person who is moving is just going to the first empty chair in whichever direction he is moving. Not just the chair immediately next to him, because that might be occupied, but to the first empty chair. So that is also not something which seems to be very easy. And then we have the people who are moving in different turns. So we have that A is moving first in turn 1, B, C, D in turns 2, 3, 4 respectively, and then A, B, C again in the last 3 turns respectively. So here what makes the set manageable is that we at least know exactly which person is moving in which turn. And then we have 2 additional points of information. Now before we come to the solution, let's take a look at the questions. So there were 4 questions here, and we can see that first question is a theta question, so there will be a unique answer for it. And even for other questions, we can see we don't have any cannot be determined option. This should have told us that at least we won't have multiple cases, and that also will make the set somewhat more manageable. Now if we come to the solution, first of course, we have to make all the diagrams. So we'll make the same diagram 8 times, 1 time for the starting positions, and then 7 other times for the 7 different turns. Now we have to follow the same numbering, of course, 1 to 7 in the clockwise direction. And now, first of all, if you look at the information given about the turns, A is moving first in turn 1, then B, C, D in the next 3 turns, and then A, B, C again. So let's just represent it with our diagram so that we don't have to read this sentence again, and it will be easy to keep track of. So in turn 1, we have that A is moving. And similarly, in turn 2, we have that B is moving. And then we have C, then we have D, and then we have A, B, C again. So this point now we don't have to read again. It will be easy to see it in front of us in the diagrams. Now if we come to the conditions, the second condition is of course what we should start with, because it has some direct information that D occupies chair 2 after turn 1. So we will have D here occupying chair number 2 after turn 1, and D is also occupying chair number 4 after turn 5. So we'll have D here as well. And then C is occupying chair 7 after turn 2. So we'll have C here. Now, before we come to the other conditions, let's explore this properly. So we know that in turn 1, A is moving. A is the only person moving in turn 1. Other people are not moving in turn 1. So for other people, their positions will remain the same. Whatever were their starting positions, they'll have the same positions after turn 1. So now if we know D's position after turn 1, and we know that D is not moving in turn 1, that means D would have had the same position at the beginning as well. D would have been in position number 2 at the starting as well. And similarly, in turn 2 also D is not moving. So whatever is D's position after turn 1, D will have the same position after turn 2. And similarly after turn 3, because in turn 3 also D is not moving, C is moving. So D will have the same position. Continuing with this, we can say that in turn number 5, A is moving. D is not moving, which means if D is in position number 4 after turn 5, D would have been in position number 4 after turn 4 as well. Because from turn 4 to turn 5, only A's position is changing. So D's position will remain the same. And similarly, D is not moving in turn 6, D is not moving in turn 7. So D's position will remain the same. And therefore, we are completely done with D. We have D's position after each and every turn. Now, if you look at the same kind of deduction for C, and of course, this is a simple deduction. We know that C is here after turn 2. So now we know that C is not moving in turn 1, C is not moving in turn 2. So C will be in the same position. So we will have C in position number 7 after turn 1 as well, and at the beginning as well. But we don't know C's position after turn 3, because C is moving in turn 3 here, and we don't know exactly where C will be moving. So now we have to come to the other points. Now, before we come to points related to turn 2 and turn 6 in the first condition, remember we had this condition in the opening paragraph, and we should always make sure that we are keeping track of conditions in the opening paragraph, not forgetting about them. So this condition was just about the starting position, that A and C are sitting next to each other, while for B and D, there are empty chairs on either side of the chairs they are sitting on. So of course, we know that D is here at the beginning, and next to D, we will have empty chairs. So chair number 1 will be empty, and chair number 3 will also be empty at the beginning. And then we have that A and C will be sitting next to each other. So now A will have to be in chair number 6 to be next to C. And then B will also have empty chairs on either side. So now B will have to be in chair number 4 so that he has empty chairs next to him. So now we have the starting positions for all the people. And now the only condition remaining is, of course, condition 1. But before we come to that, we can make a basic deduction that if B is in position 4 here, then B will be in position 4 after the next turn as well. Because in turn 1, only A is moving, B is not moving. Same position for B. Now if we come to the only other condition remaining, which is that the 4 friends occupy adjacent chairs only at the end of turn 2 and turn 6. So you can just underline turn 2 and turn 6 to keep track of this. And now, of course, let's start with turn 2 because we have the starting positions and we have the position for 3 people after turn 1. Now, we want all the 4 friends to be next to each other at the end of turn 2. If they are occupying adjacent chairs, they are next to each other. There can't be any gap between them. Now we can see that so far in turn 2, we have C in position 7 and D in position 2, but we have a gap between them. This chair position number 1. Now this position 1 has to be occupied by one of the friends because otherwise the 4 friends won't be sitting in adjacent chairs. So now we have to think this chair number 1, whom can it be occupied with? Of course, it will be A or B because we already have C and D in other chairs. So now we have to think which person out of A and B could be in chair number 1 after turn 2. Now, is it possible for B to be there? See, if you look at B, B was in chair number 4. Now, if B moves in the anti-clockwise direction here, then B will just come to chair number 3. B will not come to chair number 1. And if B moves here in the clockwise direction, B will either come to chair number 5 or chair number 6, the first empty chair in this direction. So we can see that B will not be able to come to chair 1. And therefore, that person has to be A. And therefore, we can understand that A, who was at the beginning in position 6, A will be moving clockwise like this. So that A comes to position 1 after turn 1. And then, of course, A will remain in the same position after turn 2 because only B is moving in turn 2. So that is how this gap between C and D will be occupied by A. And now if you think about B, because of course B will be moving now. So of course we can't make B move clockwise here because then B will be in 5 or 6 here and then the 4 friends, no, not even 6, B will actually be in 5. First empty chair in this direction. And if we put B in 5, the 4 friends will of course not be adjacent. And therefore B has to move in the counterclockwise direction to seat number 3. Now at least we have all their positions after turn 2. The 4 friends are sitting next to each other. And now continuing with our basic deductions. In turn number 3, only C is moving. Other people will be in their same position. So A will be still in position 1 and B will be still in position 3. And now in turn 4, only D is moving. Other people will be in their same positions. So A will still be in position 1 and B will still be in position 3. But there's one thing we can think here because we know that C is moving in turn 3. So if we look at the possibilities for C, if C moves in this direction, which is clockwise, then the first empty seat in this direction will be seat number 4. But if C comes here in seat number 4, what will happen is that ABCD will again be adjacent. They will be occupying seats 1, 2, 3, 4 after turn 3. Now, of course, that will not be valid because it was given in the condition that they are occupying adjacent chairs only at the end of turn 2 and turn 6. It cannot be at the end of turn 3 as well. And this important deduction tells us that if C can't move in this clockwise direction, C will be moving in the other direction and C will be therefore coming to seat number 6 at the end of turn 3. And now, if C is in seat number 6 after turn 3, C will be in the same position after turn 4 as well because only D is moving in turn 4. And now if you look at turn 5, only A is moving in turn 5. Other people are not moving. So B will be in the same position. And similarly, C will be in the same position. If you look at turn 6 only B is moving. C is not moving, so C will still be in the same position. And now we know that all the 4 friends are together in adjacent chairs at the end of turn 6 as well. So thinking about it similarly, we can see that between C and D, we have a gap here. Now that gap has to be occupied by one of the friends so that the friends are sitting together. So that gap will be occupied by A or B. Now, think about the possibilities. Can A occupy this gap? See, A was here at the end of turn 4, and then A will be moving in turn 5. Now, if A moves in this direction, clockwise, then A will just be occupying seat number 2, not seat number 5 that we need. And even if A moves in the other direction, A will just be occupying seat number 7. So we can see that it is not possible for A to occupy seat number 5 at the end of turn 6. So it will have to be B. So B is here, and B will of course in the next turn be moving. So B will have to move in this clockwise direction so that B can occupy the seat number 5. And therefore, B will be here between C and D. And now we have to think about A. So A, we saw that A can go to seat number 2 or to seat number 7. But of course, we need the 4 friends to be together at the end of turn 6. So that way, seat number 2 will not work. And therefore, A will have to go to seat number 7. And then A will still be in seat number 7 at the end of turn 6. And we can see, therefore, that the 4 friends will be together. Now, in turn 7, C is the only person who is moving. So A will remain in the same position. B will remain in the same position. And now we don't have anything else. We don't have any other turn. We don't have any other information. So the only thing we can say now is that C, who was in position number 6, C will be moving now in the last turn. So C will not remain in position 6. C will either go to position 1 or C will go to position 3, but C will not remain in position 6. Now we have everything. So on the basis of this diagram, let's come to the questions. The first question is a direct one. It's asking for the number of the chair initially occupied by B. So we are looking at the start, and at the start we can see that B is in chair number 4, and therefore the answer will be 4. This question is asking who sits on the chair numbered 4 at the end of turn 3. So we are looking at turn 3, and we are looking at chair number 4. So we can see chair number 4 is empty at the end of turn 3. So the answer will be therefore no one. No one is sitting in chair number 4 at the end of turn 3. So option 4. This question is asking which of the chairs are occupied at the end of turn 6. So we come to turn 6. We can see the chairs that are occupied are of course 4, 5, 6 and 7. And therefore the answer will be option 4. This question is asking which of the following best describes the friend sitting on chairs adjacent to the one occupied by B at the end of turn 7. So we come to turn 7. B is sitting on chair number 5. Now we can see that D is definitely sitting adjacent to B. Now, in chair number 6, will we have anyone else? Now we saw that C is here in chair number 6 at the end of the previous turn. But in turn 7, C will be moving. So C will definitely not be there in chair number 6. And therefore, chair number 6 will be empty. And therefore, the only person sitting next to B here will be D. And therefore, the answer is D only, which is there in option 4. Now, this set is a moderate to difficult set. I would call it more towards the moderate side if you're practicing without any time pressure. But of course, in the exam environment, this would have been a challenging set because we had a lot of deductive conditions and there would be possibilities we would have to explore until we got the right possibility. So this should have been attempted only if you are comfortable with this type of set, only if you're comfortable with number distribution, Kakuro logic, and only if you had a good bit of experience with this type of set. So here we have 5 friends who are playing a game in which each person asks a unique question to all the others. And they respond by tapping their feet either once or twice or thrice. 1 tap means yes, 2 taps mean no, and 3 taps mean maybe. So of course, we have these numbers associated with these words. Then a total of 40 taps were heard across the 5 questions. Each question received at least 1 yes, 1 no, and 1 maybe. And of course, this is a condition that is given here. And this is a condition many people would have missed out on, or they might not have paid much attention to. But this condition will, of course, be crucial to solving this set properly and to solving it without taking too much time. And then we have the various points of information. We can see we do have some direct conditions, some direct data, but we can see we have a lot of deductive data as well. So definitely a set that would have been challenging, especially in that exam environment. Now, if you look at the questions, we can see that we had just 4 questions here. And the questions would have told us that we might not get too many cases. Now, of course, there's one question which is cannot be determined. So that tells us that we might not be able to find everything. Okay, that possibility is there. But we can see the other questions are direct. So here, probably we won't get multiple cases, which might make the set manageable. Okay, but of course, it will still not be an easy set. Now, if we come to the solution, the first thing we have to think is what kind of a table should we make? So what is happening here is each of the 5 friends is asking questions, and then they are also responding to each other's questions. So there is this kind of interaction between them, like A is asking a question and B, C, D, E, all the other 4 people are responding to A's question. Similarly, B is asking a question, all the other people are responding to B's question. So because of this interaction between the people, we should make a table in which we have all the 5 people in the rows as well and in the columns as well. Similar to the table we make in tournaments for a round robin format. So this is the kind of table I'm talking about, where with respect to the rows, we can have the tabs given by the people when they are responding to a question. And in the columns, we can have the tabs received by the people when they are asking questions. And of course, we'll have the crosses because A will not be responding to A's question, B will not be responding to his own question, and so on. And we have to look at the totals because we have information given with respect to the totals as well. Now, the first thing we have to look at is that the total for all the people was 40 tabs across the 5 questions. So the final total is 40, which we can put here. Next thing, of course, we'll keep that point in mind that each question received at least 1 yes, 1 no, 1 maybe. But before that, let's come to the direct points and let's see what we can deduce from them. So the first point is, of course, a direct point that A tapped a total of 6 times. So the number of tabs given by A was 6 in total. And also A received 9 tabs to her question in total. So the tabs received by A in total was 9. Now, after this, it has also been given that she responded yes to the questions asked by both C and D. And we know that 1 tap means yes. So that means with respect to C and D, A gave 1 tap to each of their questions. Now, what deduction can we make here? Nothing as of now. So that is why we have to look at a related condition. We had a lot of information here. We had the total tabs given and received by A, and we had some specific information for 2 questions, 1, 1 here. So if you look at a related condition, we'll see that in condition 4, that no one is responding yes more than twice. Now we already know that A is responding yes twice here, 2 times, and it cannot be more than twice. So we cannot have 1 again for A here. Now if we can't have 1 again, we can have 2 or 3. And in these types of questions where we have to look at number distribution, we should always focus on minimum and maximum possibilities. They give us a very good understanding of what might be possible. So if we can't have 1 again, then minimum we can have is 2. And we can see now that only if we take the minimum of 2 here and the minimum of 2 here, only then will we get the exact total of 6 that we require. Because if we replace any of these 2's with a 3, then our total will become more than 6, which will not be valid. We need exactly 6. And of course, 2 was anyway the minimum, so we can't reduce any one of them. So we can understand that this minimum distribution is the only one that will give us this total of 6. For 2 questions, we had 1 anyway, which was anyway the minimum as well. And after that, if we cannot have 1 again, we can have 1 maximum 2 times here. And after that, the minimum that we can have is 2 and 2. And that's the only way we are getting 6. So that is one deduction we can make with respect to the first and fourth points. Now, next thing we were given is that D and E tapped a total of 11 and 9 times respectively. So D is tapping total of 11 times and E is tapping 9 times. And D responded no to B. So D gave 2 taps to B's question because no means 2 taps. Now, before we come to something else, let's analyze and try to make deductions based on this much. Here, we should also focus on large numbers and small numbers, because if we have a very large number, we might have very few possibilities for it, which might make it easy. Similarly, if we have very small numbers, for example, for this small total of 6, we can see we have just one possibility, 1, 1, 2, 2. That's the only way we'll get 6. Similarly, if you look at this very large total of 11, and out of this 11, we already have 2 here. And then we have 3 remaining values. And now we can see that the 3 remaining values here, each of them has to be the maximum possible. Each of them has to be 3, 3, 3, 3. 3, 3, 3 will give us 9. 9 plus 2 will be 11. Now, if we are getting this only by taking the maximum possible of 3, that means this is the only possibility. They are already the maximum. We can't increase any one of them. And if we decrease any one of them, the total will become less than 11. But we need exactly 11. So that is why minimum maximum possibilities help a lot in these sets. Now we are done with this point. Now if we come to the next point, B, D, and E received equal number of taps to their respective questions. So that means this total taps received by B and also for D and E, all of these three values will be the same. Now what could they be? So this is where we have to remember that condition which was given towards the beginning. Not in one of the additional points, but hidden away in a paragraph, that each question received at least one yes, one no, one maybe. Why will we connect it here? Because we are looking at number of taps that they are receiving. And this point is also about number of taps that have been received. So here, if we look at B, D, and E, we can see for D, we don't have much information with respect to taps received. We just have one value here in D's column. We don't have any other value. And for E's column, we do have two values, but they are two different values. So not very useful. This is where if we look at B, we can see something interesting. In B's column, we have two values which are exactly the same. Both of them are 2, which means both of them are no's. But as per the condition given in the paragraph, each question received at least one yes, at least one no, and at least one maybe. Here we have no's, but we need a yes as well. We need a maybe as well. So these two missing values here, one of them has to be a yes, and one of them has to be a maybe. Now, yes, maybe are 1 and 3 taps. So one of them will have either 1 tap or 3 taps, and the other one will have 3 taps or 1 tap. That is the only way in which we'll be able to satisfy that condition. And now we can see that here for B's column, the total will become 8. 1 plus 3 will become 4. And then we have 2, 2, which is another 4. So 4, 4, our total is becoming 8. And of course, D and E are receiving the same number of taps. So we'll have 8 here as well, 8 here as well. Now, we can find this missing value because we can see we have all the other totals. We have 8, 8, 8, and 9. Now, 8, 8, 8, 9 will come out to be 33 out of 40. So the remaining 40 minus 33, 7 will be here. So we have this much. Now, if we come to the 6th point, we have that Clive tapped more times in total than Badal. C tapped more times than B. So we can represent that here. The number of taps given by C will be more than the number of taps given by B. We are looking at this first because this is for the totals. Once we have all the totals, we can focus on the individual values. Now, first of all, what do we have? Out of the total 40, we have 6, 11, and 9 so far. That is 26. 40 minus 26, 14 is remaining. So the sum of these two values will be 14. If we distribute that 14 equally, it will become 7 and 7. Of course, this is not valid because one value has to be more than the other one, but this gives us a good starting point. So if we have 7, 7, now we have to decrease this value and we have to increase this value. If I decrease this 7 by 1 and I make it 6, then the other 7 has to increase by 1. It has to become 8 so that the total remains the same. The total will still be 14. And now we can see this is valid. 6 is less than 8. We still have the total of 40. Is there any other possibility? See, here we reduced from 7 to 6. Could we have further reduced to 5? And then this 8 would have been increased to 9 so that the total still remains the same. We can see that this will not be valid because we had seen in the case of A that the total of 6 is the minimum possible total for anyone. So 5 will not be possible. And of course, anything less than 5 also will not be possible. I'll take you through the logic one more time. If you think about the number of tabs given by B, in any question, the minimum number of tabs that B can give is 1. So let's say B gives 1 tap to the first question. And then again, the minimum 1 tap to the second question. So right now we are just taking the minimum 1 and 1. And of course, as per condition 4, we cannot have yes more than twice. We cannot have 1 more than twice. So now if we cannot have 1 again, the minimum we can have is 2. And then again, minimum is again 2. So we can see the minimum here has to be 1, 1, 2, 2, which is a total of 6. So if the minimum total is 6, total of 5 will of course not be possible. Anything less than 5 also will not be possible. And therefore this 6 and 8 is the only possible distribution here. Now we'll focus on finding everything else. Now, we have this condition remaining, that no one's answer to A's question matched the answer that A gave to that person's question. And this was also true for E. Let's look at A first, because we have the number of tabs given by A to all the other questions. So for A, we have 2, 1, 1, 2, which means we cannot have 2, 1, 1, 2 in A's column. For example, if A is giving 2 tabs to B's question, then B cannot be giving 2 tabs to A's question. That is what the point means. Similarly, we have A is giving 1 tab to C's question, so C cannot be giving 1 tab to A's question. Similarly, if we have 1 here, we cannot have 1 here. And similarly, if we have 2 here, we cannot have 2 here. Now, what deductions can we make? First of all, if we look at B, again, focus on very small values and very large values. They have limited possibilities. So B, we have a very small, the smallest possible total here of 6. And we've already seen, to get this minimum possible total of 6, we have to use the combination 1, 1, 2, 2. We saw that from the case of A. So this 6, we will only be able to get if we have 1, 1, 2, 2. Now we have some information here that this cannot be 2. So it will have to be 1. That is the only possibility. And now in this column, we have 1 and we have 3. That is 4. 4 out of the total 9. So the remaining 9 minus 4 will be 5. Now the only way we will get 5 is through 2 plus 3. So one of these values will be 2 and one of these values will be 3. Now we cannot have 2 here. And therefore this value will have to be 3. And therefore the other value will have to be 2. Now we are completely done with this column. Now what can we see? So we had this condition about E as well. So for example, since D is giving 3 tabs to E's question, E will not be giving 3 tabs to D's question. We will not be able to have 3 here. But now we have to remember that each question received at least 1 yes, at least 1 no, and at least 1 maybe. So if you look at D, because we have this information about D, that we cannot have 3 here. But we need to have 3 somewhere in D's column, because the question that D is asking, it would have received at least 1 maybe. So it would have received 3 tabs by some person. Now, if we cannot have 3 here, we have to think that 3 will be either here or here. But of course, we cannot have 3 in B's row, because here the total is 6. And we know that 6 will just be through 1, 1, 2, 2. There will not be any 3 here. So if we cannot have 3 here as well, we have to have 3 here. We need a 3 in this column. And therefore, 3 will definitely be here. Now, if you look at this row, if you look at C's row, because we have almost 3 values already, we can see we have a 3 here, we have a 2 here. Now, this value could be 1 or 3. If we check, if we take it to be 3, the problem will be that 2 plus 3 will already give us the total of 8. But of course, this missing value cannot be 0. Every value has to be at least 1. So that way, even if we have at least 1 here, we will get a total of 9. It will become more than 8. And therefore, this is not possible. This is not valid. So we can see that out of these 1 and 3 possibilities, we cannot have 3 here. And if we cannot have 3 here, the only possibility is 1. So we have to have 1 here. And if we have 1 here, then this cannot be 1. So this has to be 3. And now we can just try filling up the remaining values. So if we check, we can see that in C's row, we already have 3 values. We have a 2, 1, 3, that is 6 out of 8. So the 2 that is remaining will come here. And similarly, if you look at the remaining rows and columns, we can see, for example, in E's column, we already have 3 values. 2, 2, 3, that is 7 out of 8. So remaining 1 will be here. And then if you check in B's row, we have 1, 1. And therefore, the other 2 values will have to be 2 and 2. So that we get the total of 6. And then whichever rows or columns are remaining, for example, C's column, we have 1, 2, 3, that is 6 out of 7. So the remaining 1 will be here. And similarly, we can see in D's column, we have 1, 2, 3, which is 6 out of 8. Remaining 2 will be here. So this way we can fill up all the values in the table. Okay, we don't have any missing values, so we can definitely answer all the questions. So you might think that this set was manageable, and it is definitely solvable. That is why I said it's on the moderate side, but without any time pressure or exam pressure. If you think about making all of these deductions, connections during the exam, that would definitely not have been easy at all. Now, if you come to the questions, the first question is asking how many tabs did C receive for his question. So we can see that C received a total of 7 tabs for his question, and therefore the answer will be 7. Which two people tapped an equal number of times in total? So we can see that A and B, both of them tapped 6 times, equal number of times in total, and therefore the answer will be A and B in option 1. What was C's response to E's question? So we can see that number of tabs given by C to E's question was 2. Now we know that 2 tabs means no, and therefore C's response to E's question must have been no, which is in option 2. How many yes responses were received across all the questions? Now we know that yes means 1 tap. So how many times do we have 1 tap? Once, twice, thrice, 4th, 5th, and 6th. So we have a total of 6 ones, and therefore we have a total of 6 yeses. So the answer will be 6. Now this set is a moderate to difficult set. The difficult part is understanding what kind of structure we have to follow in the solution, what kind of table we have to make to represent all the data, and possibly maybe even forming equations, solving them. So the set, while you are looking at the solution, you might think that it is moderate, it is manageable, and it is actually manageable, but only if you have a very clear understanding about it and if you can think about what kind of a table we should make. In the exam scenario, of course, this would have been a difficult set. So we have a train traveling from station A to station E, passing through stations B, C, D in that order. The train has a seating capacity of 200. So maximum 200 people can be traveling on the train at any point of time. Now a ticket may be booked from any station to any other station ahead on the route, but not to any earlier station. So you can go forward, but you cannot go backward. For example, from station B, you can go to station C or D or E. But from station B, you cannot go back to station A. Then we've been given that a ticket from one station to another reserves 1 seat on every intermediate segment of the route. For example, a ticket from B to E reserves a seat in the intermediate segments B, C, C, D, D. Of course, here we have to differentiate between ticket and segment. For example, if you are booking a ticket from B to E, that means you will be getting on at B and getting off at E. But in between, you will be passing through other stations as well. You'll be passing through C and D in between. And that gives us the segments. Now we can see that segments are the distances from one station to the immediately next station. For example, from B to the next station C, that is the segment BC. Or from C to the next station D, that is the segment DD. So if you're going from B to E, first you will be going from B to C, that will be the segment. Then you will be going from C to D, that will be another segment. And then finally you will be going from D to E, and that will be one more segment. So if you take a ticket like this, you might be passing through multiple segments. We'll have to keep that in mind. And then we've been given that the occupancy factor for a segment is the total number of seats reserved in the segment as a percentage of the seating capacity. And the seating capacity is of course 200. So the occupancy factor for a segment will be number of seats reserved in the segment as a percentage of 200. And the total number of seats reserved for any segment cannot be more than 200. Then we have the various additional points. Now we can see the most of the points are about tickets. We can see in fact 4 points here are just mentioning tickets. Of course, they might be mentioning something about segment also, but we can see primarily we have to be focused on tickets. So the table that we'll make, we'll focus on finding the number of tickets for the different possibilities. But before we come to the entire solution, let's take a look at the questions and see whether they tell us anything. So here we had 5 questions, and we can see only one question was an MCQ. The others were theta questions. And theta questions, of course, will have a unique answer. And even the MCQ, it doesn't have a cannot be determined option. So that would have told us that we will not get multiple possibilities, we'll get a unique possibility. Now if we come to the solution, first of all, we have to think what kind of a table we should make. So here, of course, we have these relationships, these interactions between the stations. So we'll have all the stations in the rows and also in the columns. Same kind of format we have for round robin in tournaments. Because from any station, you can go to some other station. Like from station A, you can go to B or C or D or E. From station B, you can go to C or D or E, and so on. So the table I'm talking about is something like this, where we have all the stations in the rows and also in the columns. In the rows, we will be representing which station are you going from. And in the columns, we'll be representing which station you are going to. So if I give you one or two examples, let's say if I talk about the number of tickets we'll have here, that will be the number of tickets booked from station A to station C. Or for example, if I talk about this one, that will be the number of tickets booked from station C to station E. Now, here, of course, we'll start with those conditions which are dealing with number of tickets. So let's start with condition 2. Exactly 40 tickets were booked from B to C. So of course, this will be 40. And 30 from B to E. So this will be 30. So that was a direct condition. We don't have to look at it again. Then we have condition 4. Number of tickets booked from A to C was equal to that booked from A to E. So A to C, let's call it AC. And A to E, let's call it AE. So these were equal. And AC was higher than that from BE. Now AC and AE are equal. So both of them will be higher than that from BE. And BE was 30 here. So both of them will be more than 30. Now if we come to the next condition, no tickets were booked from A to B, B to D, and D to E. So all these values will be 0. A to B will be 0, B to D also 0, and D to E also 0. And then in the last point, we have something interesting, that the number of tickets booked for any segment was a multiple of 10. So all the values we'll get here will have to be multiples of 10. That makes things slightly easier. And we should therefore now, looking at the nature of this condition, we should connect it with condition 3. Because in condition 3, we have a fraction 4/7, where we have 7 in the denominator. So that will tell us that the value that we are looking at here, the seats reserved on segment DE, that will have to be a multiple of 7. And it will of course also have to be a multiple of 10. So this connection will make it easier to make the required deductions. Now, why am I saying that the seats reserved on segment DE has to be a multiple of 7? Because whatever is the number of seats reserved on segment DE, we have to calculate 4/7 of it. 4/7 of that. If this 7 in the denominator is not cancelled off, then the final value will also have 7 in the denominator, which means it will actually be a decimal value, which is not valid. Because if we are talking about number of seats or number of tickets or number of people, it has to be an integer value. We cannot have 2.5 seats. We cannot have 3.7 seats. And therefore, we can understand that the number of seats reserved on segment DE, since we have to calculate 4/7 of it, it has to be a multiple of 7, like 7 into x, so that the 7 gets cancelled off and we get an integer value. So this will be very useful, because if it has to be a multiple of 7 and it also has to be a multiple of 10, that means it has to be a multiple of both 7 and 10. So it has to be a multiple of the LCM of 7 and 10, which is 70. And of course, it cannot exceed 200. So what are the multiples of 70 which don't exceed 200? There are just two of them, 70 into 1 and 70 into 2. 70 into 3 would become 210. That would not be valid. So you just have to explore two possibilities here. Okay, so of course we had to use this condition given as well. Now, if we start, which tickets will be passing through the segment DE? So those tickets which are starting from station D or any station before D and going to station E or any station after E. Now, of course, we don't have any station after E. So basically those tickets which are starting from D or any station before D and going exactly to station E. So the possibilities will be, first of all, A to E. Then we will have B to E. Then we will have C to E. And then D to E. All of these tickets will definitely be passing through the segment DE. And this total, we know it has to be a multiple of 7, because we have to multiply this with 4/7. And then 4/7 of this total will be from stations before C. So out of the seats reserved on segment DE, we have to see how many of them were from stations before C. Now the stations before C are of course only A and B. So we are just looking at these two tickets. Okay, out of all these seats reserved on the segment DE, we just have to look at these two which are from stations before C. So we will have to look at AE plus BE. So basically 4/7 of this first value, which are all the seats on segment DE, will be equal to the second value, which is the seats from stations before C. Now, here, of course, we have some information already. We know that B is 30. Okay, so here also we can just represent that B will be exactly 30. Now, as we saw, because we have 7 in the denominator here in this fraction, the seats reserved on segment DE has to be a multiple of 7, also a multiple of 10, so a multiple of 70. So we saw that this will be 70 or 140. It cannot exceed 200. So first possibility is 70. Now, if this is 70, then 4/7 of it will be 40. But then the problem will be that E will become 40 minus 30, which is 10. And E will become less than B. But of course, E has to be more than B. E has to be more than 30. So 10 will not work here. And therefore, this possibility is not valid. So the possibility was taking 70 here. If 70 is not valid, then the only other possibility is 140. Okay, 70 into 2. Now, if this is 140, 4/7 of 140 will be 80. So A will become 80 minus 30, which will be 50. So we can just represent here A is 50. And of course, AC is equal to AE. So AC will also be 50. And then what can we find? Then if we have that A is 50, and we also know that DE is 0, then looking at the first equation, from 140, we can subtract 50, 30, and 0, and the remaining part will be 60. So we will get that CE is equal to 60. Now only 2 values are missing. For that, we'll have to come to the first condition. That segment CD had an occupancy factor of 95%. Only segment BC had a higher occupancy factor. Now we have total 200. So 95% of 200 will be 190. Occupancy factor of 95% means the number of seats on segment CD was 95% of the total capacity of 200. So that is 190. So on CD, we had 190 and BC is higher. But of course, it has to be a multiple of 10. So a value which is higher than 190, more than 190, and also a multiple of 10. So that is at least 200, like values like 200, 210, 220. These will be values which are more than 190 and also multiples of 10. But of course, we cannot exceed 200. We cannot exceed 200. So the only possibility here will be 200 itself. 200 will be the only value here which is higher than 190, which is not more than 200, and which is also a multiple of 10. So on the segment BC, we will have 200. Now, which tickets will be passing through segment BC? All the ones which are starting from B or any station before B and going to C or any station after C. So first of all, if we start with A, we will have A to C, and then A to D, and then A to E. All of these will be passing through segment DC. Then we can also have B to C, B to D, and D to E. And here the total has been given as 200. Now we know most of these values. We know that AC is 50. We know that AE is also 50. Then BC, we know BC is 40. BD we have seen is 0. And BE we have seen is 30. So now we can just find the missing value of AD. So adding these up, 50, 50, 40, 0, 30, that gives us a total of 170. 200 minus 170 gives us 30 here. So AD comes out to be 30. And similarly, if you look at the remaining condition that CD had an occupancy factor of 95%, so 190 seats. So you have to think which tickets will be passing through the segment CD. So tickets which are starting from C or any station before C and going to D or any station after D. So first of all, we can start with A. We can have A to D, A to E. All of these will be going through segment CD. And then we can also start with B, B to D, and B to E. And finally, we can also start with C, C to D, and C to E. So these will be the tickets which will definitely be passing through the segment CD. Now the total here is 190. And we know almost all of these values. So we know that AD is 30, AE is 50, we know that BD is 0. We know that B is 30. And out of CD and CE, we know that CE is 60. So now we can easily find the missing value. So we add these individual values, 30, 50, 0, 30, 60. That gives us a total of 170. So 190 minus 170, the remaining part is 20 here. And therefore CD will be 20. Now that we found all the required values, we can easily come to the questions and answer them pretty quickly. In this question, we have to find the occupancy factor for segment DE. Now we already saw the number of seats for segment DE. It would be 70 or 140. And 70, of course, did not work. So we got 140 as the only possible value. And now this has to be as a percentage of the total 200. So 140 by 200 into 100, that will be the occupancy factor. Okay, so we can even see this 140 by just adding up these values. All of these are tickets which are booked from station D or any station before D to station E. Okay, so for example, if you're going from A to E or B to E or C to E or D to E, you will definitely be passing through the segment DE. Finally, we are getting 140 as a percentage of 200, and that will of course be 70%. So the answer will be option 3. In this question, we have to find how many tickets were booked from station A to station E. So from A to E, we can see that we had 50 tickets, and therefore the answer will be 50. In this question, we have to find how many tickets were booked from station C. So from station C, that means we have to just add up these two values. 20 plus 60 is of course 80. And therefore the answer to this question will be 80. Here we have to find what is the difference between the number of tickets booked to station C and the number of tickets booked to station D. So we have to look at the columns. So number of tickets booked to station C will be 50 plus 40, which is 90. And number of tickets booked to station D will be 30 plus 0 plus 20, which is 50. And now we have to find the difference between these values. So 90 minus 50, that will give us the answer to be 40. Here we have to find how many tickets were booked to travel in exactly one segment. Now, exactly one segment will happen when you are going from any station to the immediately next station. For example, if you go from A to B, you'll just be passing through one segment AB. Or for example, if you go from B to C, you'll just be passing through one segment BC. So here we have to think that we'll take this 0. From A to B, we have 0 tickets. Then from B to C, we have 40 tickets. From C to D, we have 20 tickets. And from D to E, we have 0 tickets. So we just had to look at these tickets from one station to the immediately next station. Only these will give us exactly one segment. So adding these 0, 40, 20, 0, of course, that total will come out to be 60, which is the correct answer here. Now this set is a moderate to difficult set. I would call it moderate when you are solving it just like that. But of course, in the exam environment, I would call it difficult because you can see that the conditions would be pretty deductive. And we also have rating for each individual quarter, but also cumulative rating, which are the scores. So that also would have been potentially confusing. So it would not have been an easy task at all to solve this set in the exam situation. And even if you were able to solve it, it would probably have taken some time to make all the deductions. So what we have here is 6 employees, A, B, C, D, E, F. They are being split into 2 groups of 3 people each. So we have elite led by manager Kuku and novice led by manager Lalu. So we have 2 groups of 3 people each at the beginning. And then we have that at the end of each quarter, the 2 managers are handing out ratings to all the members in their respective groups. And in each group, each employee received a distinct integer rating from 1 to 3. Now we know that each group will have 3 people. And the number of distinct integer values from 1 to 3 are exactly 3 values, 1, 2, and 3. So basically, if you talk about the 3 people in the novice group, they will receive the 3 different values, 1, 2, 3 in some order. And similarly, the 3 people in the elite group, they will also receive the 3 values, 1, 2, 3 in some order. Then we have been given that the score for an employee at the end of a quarter is defined as their cumulative rating from the beginning of the year. So we have to be very careful about this. The score and the rating, it's not the same thing. Rating for a quarter, that is the individual rating for that quarter. But the score for an employee at the end of any quarter is the cumulative rating from the beginning of the year. So for any employee, their score at the end of quarter 1 will just be the rating of quarter 1. because at the end of quarter 1, that would have been the only quarter thus far. But if you talk about the score for an employee at the end of quarter 2, that score would have been the rating of quarter 1 plus the rating of quarter 2, because it has to be the cumulative rating from the beginning. Similarly, the score at the end of quarter 3 would be the rating of quarter 1 plus quarter 2 plus quarter 3. And the score at the end of quarter 4 will be the rating of all the 4 quarters combined, the sum of the ratings of all the 4 quarters. Okay, so we have to be very, very careful about the difference between score and rating. Then we have been given that at the end of each quarter, the employee in novice with the highest score, not rating, but highest score, was promoted to elite. And the employee in elite with the minimum score was demoted to novice. So this is happening at the end of each quarter. The best novice employee is being promoted to elite, and the worst elite employee is being demoted to novice. So here we have to think that there is a kind of balance. One employee will go from novice to elite, and one employee will go from elite to novice, so their totals will remain the same. Elite will continue to have 3 employees in every quarter, and novice also will continue to have 3 employees in every quarter. So that is something that will still make the set somewhat manageable. And then we have that if there was a tie in scores, the employee with the higher rating in the latest quarter was ranked higher. For example, if we have at the end of quarter 2, if 2 employees have the same score, the same cumulative rating, and we're trying to see which one of them will be promoted or demoted, we have to see the one with the higher rating in the latest quarter. That one will be the one who will be ranked higher. And then we have the various conditions. So we can see we have 3 points given, and most of them are pretty deductive. In fact, third point, of course, has some direct information, but even through that, we'll have to make some deductions. And first and second are also somewhat deductive. Now, if we come to the questions, we can see we have 5 questions here. Now, at least we know that since we have 4 theta questions, we will get a unique possibility. At least overall, we will not get too many broad cases. For 1 or 2 values, we might get multiple cases, but overall, for a lot of values, we will get unique possibilities because we do have 4 theta questions. Now, the last question is something about which of the following are necessarily true. So there we might have 1 or 2 possibilities for 1 or 2 values. We'll have to see that. So if we get started with the solution, the table will be very simple. The only things we have to focus on are the 6 employees and the 4 quarters. We'll make a very basic table like this, where we have the employees in the rows and the quarters in the columns. And then within the table, we will note down the ratings that they have got in the individual quarters, and also which category, which group they belong to, whether novice or elite. So if we get started with the first condition, A, B, C were in elite at the beginning of quarter 1. So A was in elite, same for B, and same for C. And we know that there were 3 people in each group. So if A, B, C were the 3 people in elite, then the other 3 people would have been in novice. Okay, that's a simple deduction. And then in the first condition, it's also been given that A, B, C, all of them were in novice at the beginning of quarter 4. So A, B, C, all of them had gone to novice group at the beginning of quarter 4. Now we've seen that number of people in each group will overall remain the same, because one employee will go from novice to elite and one employee will go from elite to novice in every quarter. So the totals will remain the same. So in quarter 4, if A, B, C are the 3 employees in novice, the other 3 people will be the 3 employees in elite. Okay, so that is also a simple deduction that we can use. So at least we are done with this condition 1. Now, we'll come to condition 2 later, because in condition 3, first of all, we have some direct information that the following is known about ratings given by Lalu. Now, we should think about Lalu. We should think that Lalu is leading the novice group. So here, if you're talking about ratings given by Lalu, that would have been ratings given by Lalu to members of the novice group. So whichever people we'll be talking about here, they will have to belong to the novice category. So first of all, for example, we have that B received a rating of 1 in quarter 2 from Lalu. So B is getting 1 in quarter 2, and now B has to be in the novice category in quarter 2, because he's getting the rating from Lalu, who is leading the novice category. Now, can we make some deduction here before we come to other points? It's easier to look at things one step at a time rather than looking at everything together. Then we might get confused or miss out on something. So if we look at this here, we can see that First of all, out of the 3 people in elite in quarter 1, okay, one of them is becoming novice. B is becoming novice in quarter 2. Now we know that the person with the lowest score will be demoted. So out of these 3 who are in elite, B has to be the person with the lowest score at the end of quarter 1 because B is being demoted to novice. Now the score at the end of quarter 1 will just be the rating of quarter 1. So at the end of quarter 1, that will be the only quarter thus far. And therefore, we can say that B must be having a score, a rating of 1 in quarter 1. If B is getting a rating of 1 in quarter 1, B will have a score of 1 at the end of quarter 1, which will definitely be lower than the other 2 because now A will have 2 or 3, C will have 3 or 2. Okay, we have to distribute the distinct ratings of 1 to 3 in this elite category. So B will definitely have to have the lowest rating so that B is demoted to novice in the next quarter. Okay, that is one deduction we can make. And one more thing we can see here, that if B is getting the lowest possible rating in the first 2 quarters, that means B will have the lowest possible score at the end of quarter 2. If you're getting the lowest possible rating in every quarter, then you'll keep getting the lowest possible score at the end of each quarter. And therefore, B will not be promoted to elite in quarter 3. If B has the minimum possible score, how will B be promoted? And therefore, we can say that B will still be in novice in quarter 3. Okay, so these were some deductions we should have made before we come to the next part, which is that A and D are receiving ratings of 1 and 2 in quarter 3. And of course, this is by Lalu. So they will be in novice group. So A is receiving a rating of 1 in quarter 3. And this means A will be in novice group because of Lalu. And similarly, D is receiving a rating of 2 in quarter 3 and D will therefore also be in novice. Now, some basic deductions again. We can see that here in quarter 3, we already have which 3 people will be in the novice category. And for 2 of them, we already have the rating of 1 and 2. So the third one must have the rating of 3 because they have to have distinct integer ratings from 1 to 3. So that's a simple deduction we can make. Okay, now one more thing we can see that since we already have the 3 people in novice in quarter 3, the other 3 people will be in elite in quarter 3. Okay, that's also one more simple deduction. Now that we have looked at this, we can make a similar deduction that here, if B is going from elite to novice from quarter 1 to quarter 2, the other 2 people in elite, they will remain in elite. Every quarter, one person is going from elite to novice and one person is going from novice to elite. So out of the 3 people who are there in elite in quarter 1, one of them, B, is going from elite to novice. The other 2, they will still remain in elite. So A will still be in elite in quarter 2 and C will also still be in elite in quarter 2. Okay, that is one more basic deduction. Now, if we come to the remaining condition, D and F were the only employees who got the same rating across all the quarters. And of course, we have this point in each group. Each employee received a distinct integer rating from 1 to 3. Now here, many people would have gotten confused. Many people would have felt that there is some mistake in the set, but of course, there is no mistake at all in the set. Here, if your confusion is that in the first quarter, D and F are in the same category. Both of them are in novice. So they have to get a distinct integer rating from 1 to 3. But in condition 2, it has been given that they are getting the same rating across all the quarters. So that might seem like a contradiction. Of course, we cannot satisfy both of these together if we are looking at it from that perspective. So now, if it seems like a contradiction from this perspective, we have to think that this perspective is therefore not the correct one. Maybe the language means something else. So what could be the other meaning, other possible meaning? Very simply, that D is receiving the same rating across all the quarters, which means if D is getting a rating of 2 in this quarter, D must be getting a rating of 2 in all the other quarters as well. The same rating in all the 4 quarters for D. And similarly for F, that F also must be receiving one particular rating in all the 4 quarters, the same rating in all the 4 quarters. So now we can understand that this doesn't mean that D and F are receiving the same rating. Because of course, that is not valid. D and F are in the same group here, so they cannot receive the same rating. D is receiving the same rating again and again in all the quarters, and F is receiving some other rating, because it cannot be the same, some other rating, but that rating in all the quarters. That particular same rating in all the quarters. Okay, so if one interpretation of the language doesn't work logically, you have to think about the other possible interpretation. That will have to be the correct one. Now, we already have the rating of 2 for D. So that will be the same rating across all the quarters, 2 here, 2 here, and 2 here as well. And now we can think that out of the 3 people in novice in quarter 1, whoever gets the highest possible rating of 3, that person will be promoted to elite in quarter 2. But of course, D is not getting the highest possible rating of 3. So D will not be promoted. D will still be a novice in quarter 2. Now, if you think about F, because of course we have that condition for F. Now, D is already getting a rating of 2. So F will be getting a rating of 1 or 3. Now, if F gets the rating of 1, F will have to keep getting the same rating across all the quarters. And 1 is, of course, the minimum possible rating. Now, with the minimum possible rating, F will never be promoted to elite. But we know that F has to be promoted to elite by the end. Okay, even before that, in fact. So we cannot have the rating of 1 here for F. And therefore, if we cannot have 1, we cannot have 2. It has to be 3. And now the same rating of 3 across all the quarters for F. And now if F is getting rating of 3 here, which is the highest possible rating, then of course F will be promoted to elite in quarter 2. And now we can see in quarter 2, we already have 3 people in elite. Okay, so the one missing category, that will have to be novice, so that we have 3 people in novice as well. So here at least we have the categories, the groups for each person. And there was one question based on that, which we will see later. So that question could have been answered at this stage as well. In fact, that question could have been answered without actually finding all of this. We could have just thought that just looking at the first condition, that A, B, C, all of them were in elite at the beginning and all of them were in novice at the end. So these 3 people, A, B, C, are going from elite to novice, which means the other 3 people, D, E, F, are going from novice to elite. And there are only 3 changes, like quarter 1 to quarter 2, that will be 1 change. Quarter 2 to quarter 3, another one. Quarter 3 to quarter 4, another one. So you'll just have 3 changes. In those 3 changes, these 3 people, A, B, C, will go from elite to novice. And these 3 people, D, E, F, will go from novice to elite. So basically, every person will be changing groups once. A will be changing once and going from elite to novice. Similarly for B and C. And D, E, F, each of them will be changing once and going from novice to elite. Because we have exactly 3 changes. And we do need 3 changes for these 3 people to change and these 3 people to change. So all of them can only change exactly 1 time. So even thinking about that, we could have answered one question without actually solving anything. Now if we come to the remaining part, of course, we'll just focus on this part, that every quarter, one employee will go from novice to elite and vice versa. And this will be based on the score, which is cumulative rating. Now, first of all, we can see that in quarter 1, let's make some basic deductions. So in quarter 1, we have 2 in novice and 3 in novice. Only 1 in novice is remaining. So that will of course come here. Now, similarly, if you check in quarter 2, we have 1 in novice, 2 in novice. So 3 in novice will come here. 1, 2, 3 have to be there in the same group. Now, if you look at quarter 3, we have all the 3 values for novice. Elite, we have 2 missing values. We don't know what will be the order. Now in quarter 4, we have 2 values for elite, 2 and 3. So the missing value of 1 will of course be here for elite in quarter 4. Okay, these are some simple deductions. Now we have 2 missing values in quarter 2 and 2 missing values in quarter 3. Quarter 4 values, of course, we can understand we can't find out the missing values because we don't know what is happening after that. Like who is being promoted or demoted there. So these 3 values in quarter 4, we will not be able to find. But if we now look at the 2 missing values in quarter 2, both of them are for the elite group. So of course, we'll focus on elite here. So in elite, we can see we already have the rating of 3 here. So the ratings which are remaining are 2 and 1. Now, let's check, can we have the rating of 2 here? I'm circling it so that we can keep track that this is not fixed. We can cancel it off later on if it doesn't work out. So can we have 2 here and therefore 1 here? See, we have to keep in mind that E is going from elite to novice from quarter 2 to quarter 3, whereas C is remaining in elite from quarter 2 to quarter 3. And therefore, A score will have to be either lower than C score, or it will have to be the same, and A will have to have a lower rating in the latest quarter. Now, we have two possibilities for quarter one, that either A gets 2 or 3, C gets 3 or 2. Now, if A gets 3 and C gets 2, then A score at the end of quarter 2 will be 3 plus 2, 5, and C score will be 2 plus 1, which is 3. Now, of course, in that case, C should get demoted. A should not get demoted because C will have a lower score. But of course, that is not happening. A is the one getting demoted. So A cannot have a higher score here. So this 3-2 is not working. Now, will 2-3 work? So if you have 2-3 here, then A score at the end of quarter 2 will be 2 plus 2, 4. And C score will be 3 plus 1, also 4. So their scores will be tied. Then we'll have to look at the rating in the latest quarter, which is quarter 2. And we can see that A will have rating of 2. C will have rating of 1. So A will have a higher rating and C will have a lower rating in the latest quarter. So in that case, C should be the one to get demoted. But of course, that is not happening here. So this is also not valid. So what did we see? We saw that if we give 2 to A and 1 to C in quarter 2, then none of the possibilities is working. That means this is not valid. A cannot get 2 and C cannot get 1 in quarter 2. That means it has to be the only other possibility, that A has to get 1 and C has to get 2 in quarter 2. Now, what about quarter 1? See, if A gets 3 and C gets 2 in quarter 1, then A score at the end of quarter 2 will be 3 plus 1, 4. And C score will be 2 plus 2, also 4. Then we look at the latest rating and we'll see that A has the lower rating of 1 compared to C's rating of 2. So with the lower latest rating, A will be the one to be demoted, which is actually happening. So this is perfectly valid. Even if you look at the other possibility, that A is getting 2 in quarter 1 and C is getting 3 in quarter 1. A score at the end of quarter 2 will be 2 plus 1, 3. And C score will be 3 plus 2, 5. So A will have the lower score, which means A should get demoted. And of course, that is happening here. A is the one getting demoted, not C. So we can see both of these are valid. So in quarter 1, we don't know. Quarter 1, the distribution of 2 and 3 between A and C, any one of them is possible. Now, we'll have to look at the missing values in quarter 3. So in quarter 3, both of the missing values that we can see, both of them are for the elite category. And we can see out of these two elites, one of them is becoming a novice and the other one is remaining elite. Now, in elite in quarter 3, we already have the rating of 3 here. So the only ratings remaining are 1 and 2. Now let us see whether it is possible to have rating of 2 here and rating of 1 here. If we check that, then C will be getting a score of 2 plus 2 plus 3 or 2 till the end of quarter 3. So that will be a score of either 6 or 7. But if you look at E will be getting a score of 1 plus 3 plus 1, which will just be 5. So E will definitely be getting a lower score here, which means that E should get demoted in quarter 4. But that is not happening. We can see that C is the one getting demoted in quarter 4. That tells us that this possibility is not valid. So our assumption was that C is getting 2 and E is getting 1 in quarter 3. That is not turning out to be valid. So we'll cancel it off. And circling it helps us to keep track what we had assumed. So that is not valid. So that means the only other possibility, that C will be getting 1 and E will be getting 2. This will have to be the valid possibility. Now, here if we still check for quarter 1, so we can see that E will be getting a score of 1 plus 3 plus 2, which is 6 by the end of quarter 3. Whereas C will be getting 1 plus 2 plus 2 or 3. Now, if it is 1 plus 2 plus 2, which is 5, that will be less than 6. Okay, that will be less than E score. And therefore, C will be the one getting demoted, which is exactly what is happening. So this is perfectly valid. But even if we take 3 here for C, then C will also have score of 6 and E will also have score of 6 by the end of quarter 3. So their scores will be tied. So if you look at the ratings in the latest quarter, quarter 3, C will have a lower rating. So C will have 1 and E will have 2. So of course, C will be the one getting demoted, which is actually happening. So this is also valid. So again, we can see that for quarter 1, we can't really figure out. We don't have information. Between A and C, either one of them could be getting 2 or 3. So now we can see that this is all that we can find. As I said, we don't have anything about the next quarter. This is just for 1 year. And therefore, we can't find the 3 missing values in quarter 4. So based on what we have been able to find so far, we'll come to the questions. Now in this question, we have to find E's score at the end of quarter 2. Keep in mind, it's not the rating for E in quarter 2. It's E's score at the end of quarter 2. That means E's cumulative rating till the end of quarter 2. That will be E's rating in quarter 1 plus E's rating in quarter 2. So that will be 1 plus 3, which will be 4. And therefore, the correct answer will be 4. In this question, we have to find how many employees change groups more than once up to the beginning of quarter 4. Now, we've seen that to answer this particular question, we did not have to find everything. We had to see that there are exactly 3 changes happening. Quarter 1 to quarter 2, 2 to 3, and 3 to 4, exactly 3 changes. Now, in these 3 changes, these 3 employees will be going from elite to novice, and the other 3 employees will be going from novice to elite, which means every employee will be changing group exactly once. For example, in the 3 changes, in one of them, A will be going from elite to novice. Then in one of them, B will be going from elite to novice. And one of them, C will be going from elite to novice. And similarly, in the 3 changes, in one of them, F will be going from novice to elite. One of them, E will be going from novice to elite. And one of them, D will be going from novice to elite. So even without finding everything, we could have thought that everyone must be changing exactly once. So number of employees changing more than once will of course be 0. And therefore, the correct answer here will be 0. In this question, we have to find B's score at the end of quarter 3. Again, not the rating, but the score. So for B, we have to find the sum of the ratings in the first 3 quarters. 1 plus 1 plus 3, that is 5. So that will be B's score at the end of quarter 3. In this question, we have to find for how many employees can the scores at the end of quarter 3 be determined with certainty. Now, clearly, we can determine for B and D and E and F with certainty because we know all of their ratings in the first 3 quarters. We don't have missing values for them for the first 3 quarters. But if you look at E and C, we don't know the ratings for E and C in quarter 1, which means we cannot find out their scores at the end of quarter 3. A could be 2 or 3 in quarter 1. We've seen this. And similarly, C could be 3 or 2. So we have 2 possibilities for both of them. We can't find it out with certainty. And therefore, we are only getting for the other 4 employees, B, D, E, F. So for how many employees? For 4 employees, we can find the score at the end of quarter 3 with certainty. Therefore, the answer is 4. In this question, we have to see which of the 2 given statements is necessarily true, which means definitely true. So we have something about quarter 1, that A is receiving a rating of 2 in quarter 1. Of course, we know that A can get 2 or 3 in quarter 1 and C can get 3 or 2. So A getting 2 in quarter 1, that is not necessarily true. Okay, so first statement, we cannot say that it is necessarily true. If you look at the second statement, A received a rating of 1 in quarter 2, that is definitely true. There's no doubt about it. We looked at the other possibility that was not valid. So the second statement is necessarily true. And therefore, the answer will have to be option 1, that only the second statement is necessarily true.